Okay, pay attention, Jace. Come on, let's go. Okay, so today,
Hey Jace, how are you?
the antiderivative. Now, AKA the indefinite integral. Oh, hey, TAs. Elise, come here a minute. Now, okay, here's the game. We have done some of these things. Let's start off with a nice polynomial, shall we? So if you have little f of x is equal to, okay, I don't know, x squared, okay, from when, who is he the derivative of? Here, would you take these back to Mr. Mock? That's the key that they thought they lost, but it was actually here. Oh, did they? Oh, never mind. Bring her. Never mind. Thanks. I'll give it to him later. It's fine.
Just wave by.
But later this period,
Yep.
give me that. Quit holding my hands. Later this period, we need to go out to the Bobcat skid loader out there.
Yeah.
And we need to tighten the battery cables on them. Okay? The battery cables on the battery are loose on the
That was the one
Bobcat.
that we worked on.
No.
Oh.
But we need to do that later this period. Okay?
Okay.
And I don't know, but there we go. So listen, who is he the derivative of? Well, first of all, we are going to write the antiderivative cap f. Okay, now remember when we were doing derivatives, we did f and then we did f prime. That's cute, but we can't really, if we just have f, who is his antiderivative, we just go cap f. Sure, yeah, sure. No, we're just going to do the one antiderivative. And so that's going to be, what'd you say, x cubed over 3. Listen carefully, don't forget your plus c. Because if it had a constant in, which it does, could be 0. We know what it is, so plus c. Again, x cubed over 3, any x cubed over 3. The only difference between this x cubed over 3 and this x cubed over 3 and this one, the only difference is, well, besides they look like they're crap, the only difference between them is the constant, yes? And so the derivatives will be all the same. So with the antiderivative, we have to account for this, of course. Now, so for our polynomials, if you have a polynomial, something like this, ax to the, let's do n like that. Yeah, sure, like that. Yes. What would the antiderivative be if you had this feller? First and foremost of all this, that a, we don't really care about what's going to happen to it. It's just going to tag along, right? It's just a constant, yes? X to the what power? What are you going to do with your exponent? N plus 1 over n plus 1, right? Plus c. So that's for your polynomials. Okay, once you've seen it, everyone's seen it. Yay. Okay. Okay. Now, obviously, if you do, hey, where did sine come from, man? He did come from negative cosine.
I was gonna say, Tyler, you're overthinking it.
You are, because you always ask backwards. Now, Tyler, the good news is, oh, I think it's sine. I think it's cosine. Oh, damn, cosine. The derivative of cosine is negative sine. Oh, rats, negative. Okay, happens to all of us. Just double check yourself. Pretty straightforward. Okay. Let's see. Who else do we have? Ooh, I know. Who is the antiderivative of e to the x? No, I know. He's his own grandpa. Nice. Who else have we dealt with? Who else have we dealt with? Ellen. Oh, that's a gross one. We're not going to do that one yet. We'll have that's a special one. Give me another one. Who else? It's x ln x minus x, but that's fine. What? Yeah, that doesn't have a nice. It's not one of the ones where. Hold on. It doesn't have a nice one like this, right? We have a method of doing it, but it's not how we're gonna do it. Yeah.
So if you had 3x squared, you would just immediately assume it's
X cubed, baby. Yeah, absolutely. It's 3x cubed over 3, which is just x cubed. Yeah. What else? Give me another one. So yeah, polynomials, obviously, sines, cosines, tangents, all that crap, right? But so I love what she said. So anytime we have products or quotients, there's going to be special rules for those. So they're not easy. We'll talk more about those later on. I talk about just just exact quick functions, right? Like
1 over x would just be ln of x.
Thank you. Thank you. We know that the derivative of ln is 1 over x. So the antiderivative of 1 over x is ln x. Now it is kind of important to remember it is the ln of the absolute value of x. That's different than the other one. Why? Because if you recall, next page, here is ln x. That's ln x, yes? What is his domain? X. It's non-negative. It's not true, it's positive. Non-negative would include 0, yes? Nice, so that's his domain. So we know that when we do this, all right, we're going to have 1 over x is what describes the slopes, obviously, right? But this 1 over x is only defined here, yes? Right? It's only defined there, right? When we start in this direction. But when we start the other way, 1 over x is this fella. No, that's not true, you liar. 1 over x is this fella. True that? You're like, but it's the antiderivative is ln of x, Groom. I don't think so, pal, because you cannot take the ln of a negative number, can you? No, I didn't think so. And now we're gooch. Make sense? So don't forget him. That will cause issues. Okay. What else? I really can't either. Those are the biggies, yes? Yeah. Those are our biggies. Those are our big friends. Okay. Now. So the first few of those things, you're doing a few of those. You're like, oh, I got this. It's 3x cubed plus, like for instance, if you're going to do this one here.
3x plus.
Wait, Mr. Groom. There is no, notice there's nothing up here and nothing down there. This is what we call an indefinite interval. It's how I tell you to find the antiderivative.
Okay.
Yeah. Nice.
Okay.
This function will tell you the area under the curve, but it's a function. It depends on some limits, bud, and I haven't established those yet. However, the function is not bound by that, yes? So let's check it out, dog. What is the antiderivative? Go ahead. You should probably take attendance while you're doing that. Don't look back.
It's not pretty.
Oh, listen. Life is not pretty sometimes, my friend. True dat, homie. Oh, mercy. What'd you get?
3 times x to the 5th over 5 minus 2 times x to the 3rd over 3 times, yeah.
That all?
Let's see.
Nice. I'm going to show you something really cool here in about a minute. You're going to love it. Oh, dang it. I forgot the... Oh, I got it.
Jace, are you liking this?
Jace, you having a good time with this, bud? But by the way, they are missing you. Tyler's beside himself over here. He's about crying and so forth.
I freaked out for about 5 minutes.
Okay.
I really needed to see.
Yeah, he needed to touch it, run his fingers through it, and twisted his little fingers around it and so forth. All right, sine x minus 2. Sure, I don't know, something like this. Yeah, so the antiderivative, of course, is... Actually, let's make that minus sign just for a good time. Q. Here we go. What do you got? Did I take 10? What? So, cosine?
Yeah.
Cos x.
I missed this.
All right, it's my fault. I was a jerk and put it there late, etc., etc., etc. Okay. Now, are you ready for something cool here in a minute?
Yeah.
Let the record state that Groom's going to teach some physics. Here we go. Suppose you had the following equation. Minus 9.8 dt. So t is our function this time instead of x. Ergo, what are you going to get? Well, now hold up, dog.
You're doing the anti, so you have to do 9.8x.
So hold, not x.
Or T.
So f of t is equal to negative 9.8 t
Plus C.
plus c. Okay, now hold up. Now are you watching?
Yes. That looks similar.
This looks eerily similar to, wait for it, final velocity equals, this is the acceleration due to gravity, so you can write it as gt if you will, plus, now listen friends, what would our constant be here? We're throwing down some knowledge up in this place, you know? Dude, stop it! Now listen, this is a dadgum linear equation. So if this is dollars, this is acceleration, crackhead. Listen to me. This is dollars. This better be dollars. This is meters per second. This over here better be meters.
Velocity initial.
Yes! Does that make sense?
Yeah.
Oh, dude.
Man, we don't have
Hold on.
Gosh, it'd be so crazy if you taught physics.
I know, right? But this part here was this would just now be coming together for you. With me, that's what I'm saying. But I could then, we would have learned a bejesus out of this back in the day, to where now you're just like, oh, I'm just tying the strings together. Oh, I was talking about you yesterday. This is honest to God truth. Talking to Stockwell for an hour, right here. An hour of my life. I can't get back. But anyway, an hour of my time, and in there we talked about. And I said, listen, focus. We don't talk enough about college or kids in this school. We talk too much about CTE. Huh? But whatever. And I go, okay, here's the deal. Cut them all. You're brilliant kid. Great kid. Whatever. I said, are you looking right or seeing? I said, listen, when that kid goes to college next year, I took physics. He's in for a rude awakening. Now he knows that he's going to be like blindsided, but I says that's the kind of stuff that we're having happening, like a lot of our classes at St. Helens High School. That bothers me as a teacher that works here, because I want my kids, when I taught classes, I want you to go on to the next level and go, I got this. And I don't think that's happening. Does that make sense? And that bugs me. Anyway, but back to this, sorry, but yeah. So I mentioned your name, straight up called you out. But anyway, listen, watch, look at this. Are you watching? Let's come here. And let's pretend this is some little f of t. But listen, let's call him BO, because we know who he is. You with me? You with me, dog?
Yeah.
You with me? Let's call him that. Okay. Let's antiderivative. I know. Come on. Jace is dying. You're taking too long.
Well, I'm doing it as I write it down, so it's taking a second. Yeah.
Am I right?
Plus
I haven't finished yet.
which
Hold up, dog. Hold up. Do you recognize this guy?
Yeah, I don't remember what it is.
Projectile flight.
Oh, wait, we haven't learned.
Well, that's right. You haven't learned it. But wait, Caleb, in general, check this out. In general, I normally write like this. Displacement is it's one half AT squared plus V sub OT plus initial distance for displacement, yeah?
Isn't it like crazy how the physics stuff might cover this class?
But I'm saying, listen. So when we're doing this, you would have learned a crap out of this. This would simply be, if I had been in physics, you'd learn this to death. What you'd be doing now is just going, oh, I see even more how the pieces fit. You with me? Not like learning it for the first time, but you're learning how the pieces, you're like, oh, yeah.
So wait, you can just take, if you find your final velocity equation, you have the entire thing, then you can just take it. If it's a projectile, you can then just transform it.
What do you mean transform? I know what you're saying.
So you have your entire equation for a final velocity, right?
You integrate it?
Could you then undo that and find your projectile
integrated.
Yeah,
That's what we just did.
I know. So that's how you could.
But here's one problem with that, of course. Now listen, here's something to think about. Right here, I don't know what this C is. You with me? I don't know what it is. But hold on, hold up. But when we're talking about these constants, they're really just y-intercepts, aren't they? They are the value when what? When t is 0, yes? So in other words, this is, now remember, this right here is a y value, but both of those are just y's, right? And there's a height-wise, if you will, right? So they are, well, it's y of 0 would be your c, right? You call it like the initial height. You know, does that make sense? It'd be like, where did you launch your projectile from, yes? And up here, this initial velocity, this guy here would be your velocity at 0, which we call v naught, of course, but it's just your initial velocity, right? What did it have when you launched it? Or when you were driving on the road and you hammer down the gas, then you start accelerating, but you had some initial, yes? Make sense? Does that make sense? That's all we're talking about here. Yes, right?
We're also getting really confused often if we ever use it.
But does this make sense? This is all we're talking about here. Yes? We're good? Now, a couple things to think about this. Let's come back to this guy here. If this is acceleration in time, and let's say you had a 2 meter per second acceleration, a constant. Yes? What would that look like? Well, it would look like this, yes? Okay, that's cool. Cool. And out here to some value of x, or out to some value of t, okay? Let's just out here to some value of t. Okay, how fast will we be going? In other words, right? That's what you'd be asking me. If I am accelerating at 2 meters per second, how fast am I going, Mr. Groom? Well, there's two things you'd have to, are you with me? Yeah. You're going to accelerate at 2 meters per second squared. 2 meters per second squared, sorry. That is, you're going to accelerate at 2 meters per second every second, right? How fast are you going now? But there's two things I have to know before I can answer that question. What are they? Time, how long did I do it for, and how fast you went with. Yes? In other words, when I do this problem, no, wait a minute. How fast, right? So I am solving for this. Yes? But to know that, I need to know time equals blah. I need to know that. And I need to know, well, where did you start? Right? I need to know those two values, yes? This guy here is my C. Right? That's my C. So let's check this out. Caleb, pick me an initial speed, sir. What? One? Initial. Oh, sorry. What would you like for our initial speed to be, sir? 7 meters per second. Oh, that's just cute. Okay. And how long would you like to accelerate for, Kaylin? 5 seconds. That's bitching. Now, Mr. I feel like, well, that's going to be, how fast am I going? You tell me. You tell me, how fast am I going to be going? Well, I don't even need to do calculus at this point. You're like, duh, Groom, it's 17, isn't it? It's 17, is it not? Right? Meter second? Times 2. But listen, here's the dealio. Right now, I'm saying the acceleration is equal to t. No, it's not, dumbass. It's equal to 2. Right? And this acceleration is the derivative of... It's the change in velocity. Good. So if I were to integrate this guy, I would get back to velocity. That makes sense? The antiderivative of acceleration is velocity. Now think about that for a minute. The derivative of velocity is acceleration, yes? So the antiderivative of acceleration gets you back to velocity. We'll give you a minute to clean up the brain splash at your house, Jace.
So you would have done
what?
all this in physics class?
Okay, again, in physics, we would have hammered the hell out of motion. Okay, chapter 1 and chapter 2, I would have hammered this to the point where, listen, there's 4 formulas, which I'll write down momentarily. And you will have memorized those 4 formulas. But the book has 17, yes, because they take each one of these and solve for every other variable. Exactly, if you don't know how to do algebra. Sorry, if you do algebra, you don't belong with this. So get out. So there's 4 formulas. You memorize those 4 formulas, you can do them all. So what I'm doing now, and what I would have said to you, the definition of acceleration, by definition, what is it? It's change in velocity over time. Wait, that sounds like a what? Change in velocity with respect to time sounds like a derivative. So if I anti-derivative that, where do I get back to? Where I come from, which is velocity. Makes sense. What? Well, I wouldn't listen. No, not in chapter 1 and 2. But in calculus, most of you can calculus at the same time. A lot of you. In calculus, but no, in physics, it started here, because that's when we're starting to do derivatives. We're doing that projectiles and all that stuff. I hint at it while we're doing it. By the way, it's a derivative. Except why and I keep hammering that long way, right? And then now, when we're starting to do integrals, I'm like, oh, by the way, we're going to do this, so it's gas backwards. Backwards. Does it make sense? It just ties it together. They go together. See, like, years ago, they wanted me to teach advanced placement or physics, right? I said, no, it's boring. It's boring. It's nothing to make you boring. I don't cover as much stuff. I said, no, I'm doing that. And then it was just going to be algebra-based physics. I said, no. That's what we already do. I want to do more with algebra-based physics. But I'm going to bring calculus in when I can for the kids to go on. So then when you go to college next year, you already taken calculus.
Look at it.
And so now you jump, but now you are in physics using calculus. You're like, in my mind, you know physics because you pick it from calculus because you know physics concepts because you pick it from me. The only difference is instead of going, work is 4 times the distance, you're going to integrate. Fine. That's the only difference, right? And because it's got to be a constant force. Right? Does that make sense? Because in life, when is the last time you do a lot of constant stuff? Things change, right? That's what calculus is for, baby.
The class trying to figure out what you did wrong in one of its problems.
Gotcha. Okay, so here we go. Back to this. So, calculus is the math of change, Jace. All right, here we go. So, acceleration. So, listen. So, velocity. So this is going to be cap f of t, which again is velocity. Velocity is at plus some c, yes? But because this is a velocity, it's I don't know, I guess I'd call it a final velocity. It would be equal to the change plus an initial velocity. That's why we call them that in those classes. Does that make sense? Because it's an applied situation, right? If you go to McDonald's, you're going to get a soda and some Big Macs. The soda is your constant. That's right. Mr. Jim, I didn't get a constant. I didn't get a soda. Still got a constant, baby. It's a big fat goose egg. And then every time, it's the same principle. Does that make sense? Nice. So here we go. Now, if I wanted to integrate this feller, listen, what is the antiderivative? Or in other words, velocity is the change in displacement over time, yes? So if I anti-derivative, I get displacement, we call it, as a function of time, is equal to, well, 1/2 at squared plus v sub ot plus some constant. And what would you call that constant? Well, it would be your initial displacement, yes? Right? So we would typically just refer to this as our initial displacement. That's it. NASDAQ's down today. Ooh, the S&P is dropping 0.5%. No. Okay, stop it. I'm going to write this up. I'm going to write this down. I'm going to show you a little physics trick for this. Now watch. The 4 formulas that you should have memorized are this. Constant speed. I go this fast, yes? You with me? Piece of cake, yes? Wait, what is the definition of acceleration? The definition of acceleration is the change in velocity over time. True that? By the way, if you turn this guy inside out, you get v sub f equals v sub o plus at, yes? Which is the antiderivative we just looked at a minute ago, yes? But I memorized it this way because it's literally the definition of acceleration. Yes? There's what I like to refer to as the grand poobah. It's not a physics term, so don't go look it up. That's what Fred Flintstone used to say. It's the grand poobah in its X version, or if you prefer its Y version, In the y version, it has to do with gravity on Earth. Of course, if you go to outer space, it is different. So don't come crying to me when you try to put in 9.8 on the moon and it don't work. Okay, it's only for the Earth surface sorts of things. Those are the same formula, yes, basically. Yes, with a specific, we're going up and down in this case. We're going side to side in that case over there, yes? And specifically put in an A of negative 9.8, yes, over here? Nice. And then the last one marries this fella and this guy together, and you get this guy. Notice what's missing on that bottom equation compared to the other ones? Time's kind of a hard thing to measure when you're hauling amps. Things going 5 zillion miles an hour, but distance is very easy to measure. So that one's very nice. So you could get in here and solve for like acceleration pretty straightforwardly based on the velocities and then the distance. Okay, especially like for instance skid marks. Hey, skid marks on a road. Yeah, this is if you're doing skid not in your underpants. Skid marks on the road, and you're now analyzing a crime scene or a collision scene. They use this guy, right? They can measure the distance and see how fast the person was estimated to be traveling. Because they have a pretty good idea. Tires on pavement, I should have this. Wait, you don't know about friction. Certain amount of friction, ergo I can find out what my acceleration should be, and then I could be able to figure out, well, if we slid this far, he must have been going this fast. Yes, make sense? So those are the 4 formulas that you should have memorized in like chapter 1, basically. And so that's it. But see, if you can see how they all come from what we're talking about. The last one is a substitution problem. Okay? Now, group. So far, so bueno, but they're just antiderivatives. I agree. How about if I asked you this question? How far do I go between 2 and 5 seconds if I originally was going 6 meters a second and accelerate at 3 meters per second squared? I don't know either, but I do know that the antiderivative, right? The antiderivative of this equation, which I was going 6 plus 3t, you can write it in any order. 3t plus 6 is the same. Yeah, same. And there, listen, but hold up, bruh. I said between 2 and 5. You see the diff? Now, watch carefully. What do? Well, the first thing I do is I take the antiderivative, which of course would be 6t plus 3t squared over 2 that. And you're like, but groom, plus c. Now this is the only time I'm going to do this for you, Caleb, because I like you. I'm going to put it there right now. But this is the only time I'm doing it, bud. The only time. I want you to see this, bud. Now, we're going to evaluate this from 2 to 5. So, what we're going to end up doing is, what does that mean? It means we're going to go 6 times 5 plus 3, 5 squared over 2 plus c minus, big fat parentheses, 6 times 2 plus 3 t squared, 3 times 2 squared, you dumbass, over 2 plus c. That right there is the distance between those two values. What's going to happen to my C's, baby? Bye-bye. So, when we are doing, listen carefully, this is what's referred to as a definite integral. Because there's a definite integral, when you minus, the C's go away, yes? And so we will never, ever include the C on a definite integral. Because what's going to happen to it? Because it'll be the same C. True that? True that. So we do this. We end up getting 30, it's 45 over 2, I guess. Is that right? No, 75 over 2 is 37.5. Minus 12 minus 6. Is that right? Plus, yeah, minus, yeah, right? I feel like that's right. Groom. 49.5. We gooch. Thank. Let the record state that Groom had a question. Mr. Malden asked if he could answer it for me. Thank you. Well, what's happening out there? Okay. Can you get that Tahoe up in the air? You get that Tahoe up in the air as soon as, well, Levi can do it. Have them put that Tahoe up in the air. I'm gonna go in there and tighten that bolt real quick, and then once it's out, I'm gonna get the Bronco up in the air so I can work on the exhaust later. Thanks. Have him do it. You're not the only guy that works around here. Get one of those dingheads to help you. Now, 6 plus 3 over 2. If a guy were to plus 6 plus 3, let's try it again. 6 plus 3t. Yes, that would look something like 1, 2, 3, 4, 5, 6. Something like this. Yes. What would happen if I found the area between 0 and 2? Between 0 and 2. Now hold on. That would be the distance that I travel between 0 and 2. You with me? Hold on. And what if, let me get a different pen. Listen, Caleb, I'm excited because you can see it coming, bud. Bud, you could see it coming, can't you? Here's 5. Yeah? If I found the distance between 0 and 5, it would be this business, yes? In fact, this would be f of 5. True that? And in fact, this would be f of 2. True that? And so the distance between them would be what? We minus that part off where they overlap. This is what we refer to as the fundamental theorem of calculus. You must say it that way. There was a guy I had as a teacher, he's a Japanese feller at Portland Community College years ago. Kin Kitaguchi. He smokes, I'm not joking, 6 or 7 packs of cigarettes a day. He would light the one with the next one. Let's go! He'd walk across campus. He would smoke one big heater right before he ran the door. He would run to the board and he would talk 100 miles an hour for about 45 minutes. Break time! And he'd race out to the back and he'd smoke 5 cigarettes in 10 minutes. And then he'd go, let's go! And he'd back in. Anyway, some years ago, he quit cold turkey. Just cold turkey. I'm not smoking anymore, and he's done. But anyways, great man, wonderful guy. But instead of saying we're going to integrate, he said, and now we will invoke the fundamental theorem of calculus. Yes. Instead of integrating, that's what he would say. He's a nut. Great guy. Anyway, hilarious. Anyway, when my youngest was born, I aced the midterm. Kicked its ass. The final comes around. Bo was born the week before the final? The week before the final. Like, I got no sleep. The final was not good. I told him, I'm sorry, buddy. He goes, you got 70-something on the final. Yeah, there's an 88.2 in the class. Looks like an A to me. That's exactly how I said it. I'm like, nice. Thanks, pal. Great guy. Anyway, let's invoke the fundamental theorem of calculus. So the game is thus. You're going to integrate f of t dt from A to B. Literally, it is f of A. Oh, sorry, no, it's not, dumbass. F of B minus f of A. That's it. That is the fundamental theorem of calculus. You're welcome. Bruh. No, Isaac was all about differential calculus. This is my man Archimedes. Back in the day, was one of the very first guys. You mean integral calculus, second semester predates differential calculus? Yeah, by thousands of years, dog. By thousands of years. The ideas of it. Now, it wasn't until much later that they kind of realized, whoa, they're two sides of the same coin. They didn't look at it that way. What? Yeah, so it's right here. We good? Now, the hardest part, kid, I'm not kidding, Kaylin. The hard part is finding the antiderivative. So we will spend most of second semester learning how to find antiderivative. That's the one that's the biatch. Because if all of life was a sine curve, we'd be gooch. Okay? It's not. It's things like, what about this? Can we please do a division one? Yeah, you're not going to want to do that, but we will. But you're not going to be happy.
Why?
Yeah. You will want to do composite functions. You're not any better.
I said that last.
You will want to do multiplications, and you are the worst of all of us. They all are going to suck. But the point is,
What about jace?
I don't know what jace will want, but I'm sure he'll screw something up. But anyways, the point will be finding the cap F, the antiderivative is the hardest part. The rest is a piece of cake. It really is. Okay? So let's do some. Now, hypothetically, Kaylin, you have, give me, who are two of your functions, dear? Yes, correct.
Okay.
Okay, good. Hey, I will get that ordered and see you when you come. Jerry already approved it. So one of my former students, love her to death. She's great. She's working on being an electrician, but she is very scared of talking to people and stuff. But I told her she's speaking in my class, and so I told her that her boss already approved her coming in and whatnot. And I'm buying her lunch, and she's like, whatever. And then she replied back earlier today. She's like, I'm not. I'm like, no, your boss already approved it, and I've already spoken to him. You're coming in. And she's like, no way. I'm like, oh yeah, no, you're coming. Yeah. But she's awesome. Okay, check this out. So who are two of your functions? I'm ignoring him for a second. Go ahead.
3 sine x over 2.
Okay, so 3 sine x over 2 in parentheses x over 2? Okay. Okay.
And then negative x squared minus 6x to the 4th plus 10x.
And I need to find the area between them, between where and where, dear? What are my limits of integration?
Let's do 5 and 10.
Is this hypothetical from our assignment, like I wanted you to be? Hypothetical? Is it exactly off your assignment?
No, 0.
Really? 0 and 10?
I was just making these numbers up.
On your paper, pick one of your regions. I'm trying to help you. This is going to be part of the assignment for you guys on your assignment. I will probably do one for each of you because that's the kind of guy I am. Pick one of them.
I'm trying.
For God's sakes, what's up? Yeah, I'll go show you what. Come here, I'll sign it real quick. You pick one too. You pick one too.
Oh, you want me to?
Yeah, both. If they all three, pick one.
I don't know. So. Means I got pulled off my
He's showing him on the Tahoe. He's not on the Tahoe.
Don't do log. I don't want to learn log today. I don't want to learn natural log. Those are 2 of them. Got 3 other ones.
No, look, this is natural log. This is negative log. This is okay. This is absolute value.
Absolute value and cosine do it. I gotta log into my Chromebook and then just set it.
Keys are over here on my desk.
Right now.
Okay, Kayla, you got it?
Yeah.
What is it?
0 to 1.077.
Oh, the same one we did before?
Maybe.
Was it sine x squared? Sine x over 2, I mean?
Yeah. And then times by 3.
Okay.
Yeah.
Is this the top function or the bottom function? Okay, so minus. So minus.
It all saved in my Chromebook.
Wait, no, it's the bottom. Bottom. Sorry.
Okay, so we're gonna flip it around. Go ahead.
Okay,
You got this.
you have negative x squared minus 6x to the fourth plus 10x
Minus
minus that.
sine of x over 2.
3.
Oh, sorry, 3. Yeah. Now,
That's from 0 to 1.77.
1.077.
Yeah.
Okay, so let's take the antiderivative here. So it's going to be negative x cubed over 3. Is that right? Minus 6x to the 5th over 5. Plus 10x squared over 2, which of course is 5x squared. But no need to simplify it if you don't want to right now. Now, I'm about to let you in on a secret here. Okay, this is a little tricky because x over 2 is a function in a function. You with me? But I'm going to let you figure it out here. Okay, we'll do it later, but I'm just going to give you the hint here. Okay, where did negative sign come from? Positive cosine, right? So this is clearly going to be positive 3 cosine x over 2, but there's going to be times 2 out front for no apparent reason right now. But you can see, but you know why? Because you take the derivative of this, that's the times the derivative of the inside, which is a half. A half times the 2 kills it. You with me? So it's kind of like chain rule, only ass backwards, yes? Nice, now here we go. And then we're going to go, bam, 0 to 1.077. Would you please, you guys, do this and then confirm with Kaylin what the answer is compared to her Excel? Let's try it. Punch it in and see what you get. And then you get out your Excel and see where we're at. Okay?
There's no point in doing that.
Still working out the deets. Fridays are good for you, right? Fridays.
So plus 6 cosine of x.
She's so cute. She's like, and what day is this supposedly taking place? She's already given in. She's already going to do it. I know she would. What a great kid. Like everybody, she's quiet. Of course, she's smart enough. I don't like it. They strike something out. They like that massive kid. What a great kid.
That's better.
What a great kid. All right, so where are we? Which one? Did you get
Almost there.
3.6443906.
They put in Excel, you think they have
2.79.
Whoops-a-daisy. Let's figure it out. Groom's going to do the math. So, Groom's going to whip it out here and see what's up. That sounded weird. Okay. So, here we go. Groom's going to type it in. He's going to go negative x cubed divided by 3 minus 6x to the 5 divided by 5. Is that right? Yes. Plus 5x squared over 2. Plus 6 cos x over 2. Such that x equals 1.077.
You have properties?
I do.
Yep, I got that number.
But
And then I plug in
Oh, you know what?
it as 0, and I get
I didn't do my parentheses.
6.
and then if I take 8.79 minus 6,
2.79. 5.
bam! Yeah. Isn't that cool? Let's try one of your guys's from your assignment. Shall we?
Whether you want to go first or.
I gotta find the.
Okay, whip one out real quick there. Let's go, Caleb.
Here, I got equations.
Oh, okay. All right.
7
Hang on.
times cosine of x minus 15.
7 cosine of x minus 15.
No, 15 inside.
Oh, okay, that's bitching. Hang on, this is easy. Now hold on. You're like, is that going to change things? No. All that did was shift you. Listen, this is exciting.
Pick it up and move it.
Did the derivative change? No. But where it changed happens, yes? So the same derivative will happen, except where? Shifted over 15 units. Are you with me, babe? So what's the rest of it?
Plus 6 on
Okay, that's one. What's the second one?
and the other one is the absolute value of 9 times x minus 7.
So you're doing so your cosine one's the big one.
Minus 14.
Okay,
No, minus 14.
okay, listen. We're not going to do that one. That's a little too much of a stretch
Okay, well, I have.
for the first day. You with me?
Okay, fine.
Okay, well, we'll just go to Caleb then. We'll just go to Caleb. That's we can do it, but that's much later on, right? I can convince you of the x minus 15 with the absolute value. That's a bugger. Okay, that's just a mess.
Let's just
Kill the LN one.
No, that's fine. It's fine. Yeah, let's stick with the easier ones for right now.
Okay, so you want the bigger one first, right?
Well, I want the top one first.
Yeah. Okay.
Right.
So
Hey, smile. You're in your damn happy place out here, pal. Okay, let's go.
tangent of x over 2.
Not today.
No.
Listen, listen. If you did secant squared, I'd be like, dude, the integral of secant squared is tangent.
Right. It's tangent.
But the integral of tangent is, where did it come from? That's a mess. We'll do that later. It's going to be having ln of a secant and stuff. It's a good time. Yeah, go ahead.
Sine x plus 2.
Inside x plus 2 or just
No,
x?
outside.
Okay, bitchin'. Mm-hmm.
And the second one is 2 times x minus 5 to the 4th minus 4x.
Like that?
Yeah.
Okay. We can do this, but we're going to have to do a little bit of algebra first, okay? So we'll do a little bit of algebra first. So x minus 5 to the 4th power, I'm going to go ahead and blow that up because you don't know how to do that yet. Later on, it'll be really obvious. You like, doesn't it kind of look like x to the 4th power? Doesn't x minus 5 to the 4th kind of look like just x to the 4th? Won't it have the same derivative, but just, scooched over? Yeah, it will. So it'll be, or same integral, I should say. Yeah, same integral. Yeah. Just scooched over. So that's a transition. Matter of fact, screw that. We're just gonna do it that way. Here we go. So, from where to where, sir? From where to where?
From okay. 0 to 3.39.
She's probably in there complaining to her boss. You told Groom I would do that? I'm such a liar. From whence did cosine come?
Sine.
Or sorry, from when did sine come?
Negative cosine.
Negative cosine. And from whence did the 2 come? Who is he the derivative of? Now, I want you to use your thinking caps, children. This x minus 5 looks a lot like x to the 4th power. So if you thought about integrating this, you probably would do minus 2 x minus 5 to the divided by 5. Now, by the way, that works, but it only works because there's an x inside. Are you with me? Later on, that won't work if there's like a 3x. You with me? We have to do something a little bit different. All right, go ahead. Then what? Plus 2x squared?
Yeah.
Is that right? Yeah.
Yeah, minus 2.
Like, what? What? The Bronco? Listen. Okay, listen. Old school Ford, you can not this. You have to like the other get it. Pussy. Here we go. So let's type this in. So neg cosine, negative cos x plus 2x minus 2 parentheses x minus 5 to the 5 divided by 5 plus 2x squared such that x equals 3.39. 35? 35? And then what's the other one? At 0. Listen, all of those guys have
They'll have
an
an X.
X? Interesting. Interesting. I may have typed something in wrong, but let's see what happens here. So, well, that makes sense because cosine of x is 1.
Yeah.
Or cosine of 0 is 1, rather. And then x minus 5 is negative 5. So, this is somewhat troubling. Because if I did 35 minus 1249, turns out that's negative. Let's look at your picture on the big screen, actually. So let's go to the big screen, to Desmos. Let's go see what's up. Desmos.com. And so what was your equation? Sine x? No, it's
Plus 2.
sine x plus 2. And then the other one was
2 times x minus 5.
2 parentheses x minus 5 to the 4
Minus 4x.
minus 4x. Not, oh, I see what happened. Can you see what happened? You were trying to find this region in here, yes? What region were you trying to find?
Region.
What first region? Where? Up here?
Down 1.
Right here.
Yeah.
So, oh, I see what you're doing, sir. So x equal, what was the number? What was our number? 3.9. That is hot. Now, what you're actually trying to find is that little sliver right there, sir. So who minus who? It's going to be red, which is the sine, minus the blue, from 3.39 until whatever this x-axis, or no, that's 3.39. We need to figure out where the blue crosses it up here. You with me? And so it should be,
3.34.
that's what we need to do. So we need to do sine. Did we do sine? We did sine, didn't we? We did sine first? We did. But we need to go from, where did we say? 3.34 to 3.39. Yes? And when I look at that graph, I go, geez, that's a tiny little region, yes? Now the good news is, look at this. You know what's exciting? I don't have to do any of that dang antiderivative crap anymore. All I do is reevaluate. Ah, there you go. What's this? What's this?
See, right? You just double check.
Ah, I'm just saying. Now, what was the original one? Did I do this one right already?
Yeah, you just.
Good for me. Now, and then Hey, it's 35
Really kind
minus 35.05. Bam. That is why we love this crap, Caleb. The other night, this young feller in my OIT class, they had to do this assignment to gather GPS data. He was writing his little card. He said he's pulling little cards. He goes 4 miles an hour. He went out and drove around. Can you look at my data? So I'm looking at data. Data looks, I can't really tell you all the data. I see the speed, his velocity, 340 feet per second. Now I'm a nerd, so that's Mach 1. That's the speed thing. Follow? Thanks.
A little bit fast.
So I go back, look at it. Well, he got bad data. Good bad data. So everything he did was pretty good. He said bad data to start with, and so what are you gonna do, right? But that's it. And so you're like, that didn't make sense. I am not doing Mach 1. You look at your picture. Negative 1200. I'm no mathematician, but if you zoom in, oh, 105. That's tiny. And the crowd's so fine. That makes sense. Anyway, listen. I still want you using Excel to do the work because most of the ones I had you pick, were ones that you cannot integrate yet. Okay, but I want you to see where we're going. Yes.
X.
Now, on the homework page, where are we at here? The homework, I got my glasses back on. Page 307, where's my book? Well, piddle, can't find the book. Well, it's here somewhere. Anyway, somewhere I have a book. I believe it's page 307. It's the definite integrals page. Do you have your book with you, dear? Anyway, it's page 307. Listen with me. I don't care. I'm just telling you. That's what I'm going to work on today. Is to get the integrals on page 307. So your introductory page. It'll be like, oh, 3x squared plus 5 from 2 to 7. You're like, ooh, 7. Okay, well. Now, again, the cool thing about this, and I want this to be clear in your head, people. Clear in your head. This is exciting. Watch carefully. The fundamental theorem of calculus says this. From A to B of some f of x dx is equal to f of b minus f of a. And we've shown a few of these, but here's what I want you to see. I, in my mind, always go from 0 to a like so, and this is f of a, and then 0 to b, and of course, this is f of b, yes?
The farther one this way, you subtract the shorter one from the longer.
Correct. But what I want to be clear is this. I usually draw the picture such that I'm going to 0. You with me? Shh, don't tell anyone. But as long as we start at the same place, we don't even have to start at 0. Are we right? You with me, dog? Because in reality, this could also be written as, check this out, the integral from c, some c value, to a, well, sorry, some c value to b of f of x dx minus this guy, f of x dx. It's the same thing, isn't it? Because what's going to happen? It's fb minus fc minus fa minus fc. The fc's go bye-bye. In other words, it doesn't matter, although in my mind I feel like it's easier to start at 0. You with me? Does that make sense? You don't have to. And it just ends up being this deal right here. Make sense? So I want you working on page 307 this weekend. And on Monday we'll kind of pick up. Again, most of what we do the rest of the year will simply be finding new ways, well, to punish you and hurt your feelings and make you feel stupid. But mostly finding antiderivatives. Finding antiderivatives are kind of a mess. Are you with me? The process, this part here, any idiot can do. But finding the antiderivative, that's the thing that's kind of she's not a nice person. Yeah, okay? All right. Say goodbye to Jace, everyone. Bye, Jace.